VR Academy. Welcome to our YouTube channel.
Hello there, greetings and welcome to another editorial on VR Academy's YouTube channel. If you are new to our channel and find our videos to be useful, then don't forget to like and subscribe. So let's get started today. So the question I'll be handling in today's video is regarding the Newtonian mechanics. One of the questions which students have to suffer a lot while studying that, and which is how we can derive the first law of motion called the law of inertia from the second law, which is F is equals to ma, the mathematical formula to calculate force acting on an object. So how can we derive the first law from the second law itself? In other words, how the second law of motion, which is the most important law of Newton, how the second law inherently contains the first law, and can we prove that mathematically? And I'll be using the board and we'll solve this because students get asked a lot about this question in their exams. Is one of the key questions which get asked because it checks whether you know the both laws or not, your knowledge of both of them. So it's a favorite one amongst the examiners. So let's handle that in today's video and solve it permanently, so you have no doubts in your head and you're totally fine with your Newtonian mechanics. Now you can see the task at our hand on the board itself, how we have to derive the first law of motion from the equation of the second law. Now this really helps you because in this way two benefits are there. One, you don't have to memorize both the laws, which becomes tough with the kids because they are like, you have to memorize three of them. The point is, if you understand this, you just have to memorize one law, which is the second law, and the first law just makes sense to you. Second, because you're understanding physics and the language of physics is mathematics, so your conceptual clarity becomes even more firm if you can prove it mathematically. So maths really helps you get the idea more, like concretely in your head, that how it can be proved even mathematically. It strengthens your conceptual clarity and you get to score more if you, after the statement which you have stated in the exam, if you can mathematically give us the formula. So let's begin by first understanding what are the two laws. Let's understand their statement, what do they say, and then try to prove that the first law is actually contained in the second law. You don't have to memorize it. This equation F is equals to ma, which is the second law of motion, inherently contains this one. So first let's get to the first law of motion and understand what it says. The first law of motion is also called the law of inertia because it revolves around the concept of inertia. So if you don't understand inertia, the first law is not going to make much sense to you. But I've got you covered. I'll explain in a while what inertia is. So the first law states, Newton says an object maintains its state of inertia. See, that's where the word comes. Now what is inertia? Inertia is a tendency of objects which has mass, which is equivalent to something like laziness. In whatever state the object is in originally, the object wants to stay in that state. So if an object is at rest, they want to stay at rest. If the object is in motion, then they want to stay in motion. So inertia is equivalent to a tendency of the object in which they want to stay in whatever state they are already, unless there is a condition, unless acted upon by a force. So Newton says that an object in whatever state they are, if they are at rest, they'll stay at rest. If they are in motion, they'll stay in motion naturally, unless they are acted upon by a force. Now this force needs to have two qualities. I did not write it here because I wanted to explain and also look important. Now the force should be external in the sense that it should be acting from the outside on the object. It should not come from within, because if the force was coming from within, it would have broken its inertia. So the force which breaks the inertia, which breaks the laziness, which is like the kick the object needs to get out of its state of motion, that force must be external. It will come from outside the object and never from inside, because we see all around us that the objects, in whichever state they are in, they continue to stay in that state unless acted upon by a force which is external. And the second one, the force should be unbalanced. Unbalanced force again is a key concept. Unbalanced means that there should be some net force acting on it. Balanced means that the force should not be equal in magnitude and opposite in direction, because then they just cancel each other out. So like 10 newtons from here and 10 newtons from here, so 10 minus 10 is 0. So Newton says the force should also be unbalanced in the sense that there should be some net force acting on, there should be some actual force acting on the object, and the forces should not cancel each other out. So the first law in simple terms now mean law of inertia, that an object maintains its state of inertia, that it will continue to be in whatever state it is, unless it is acted upon by a force which is both external and which is unbalanced. Now I hope that makes sense. Now this is like the theoretical conceptual knowledge of the first law. If I want to prove it mathematically, then I have to turn it into mathematics, and now I'll explain you that inertia can be mathematically represented as well, which is going to be really useful when we are going to prove it from the second law of motion, which is the mathematical formula of calculating the force acting on an object. With the first law firmly clear in your mind, now let me get how we can prove inertia mathematically, or what does inertia mean if we have to prove it mathematically. So like I said, inertia is the tendency of the object. It means that an object is not changing its state of motion. which can just be said in this way, that it is not accelerating, which means that there is no change in its velocity. Its initial velocity is equals to its final velocity. So in the state of inertia of an object, the object is not accelerating at all. Now let me explain it further. For example, imagine this ball. It is an object with certain mass and it is at rest. If it is at rest, then its initial velocity is equals to 0 meter per second. Now inertia says that if this object is at rest, then it will continue to stay at rest, which means its final velocity will also be equal to 0. So its initial velocity is 0, and because it is at rest, it will continue to stay at rest after no matter how much time we are talking about, 15, 20 seconds, infinity, whatever it is. If this object is at inertia, then its initial velocity and final velocity will be the same, which means that it is not accelerating, again the same point. Similarly, inertia should not only be associated with objects just at rest. Inertia also works with objects which are already in motion. Now imagine there is an object m which is moving at an initial velocity of 2 meter per second. Inertia would say that if it is moving at 2 meter per second, then even after some time it will continue to move at 2 meter per second. In this case as well, you will see the acceleration would come out to be 0, because v minus u by t, 2 minus 2 by t, 0 by t is equals to 0 meter per second square. So in the state of inertia, from both these examples, we see that an object at rest continues to stay at rest, which means its initial and final velocity are both going to be 0. Similarly, if an object is in motion, it will continue to stay in motion, in the sense if it is moving at 2 meter per second initially, it will continue to move at 2 meter per second finally, and even in this case there is no acceleration. Now if you get this thing in your head, then the second part of it, which is the main part of the question, that can we derive the first law of motion from the second law, will make absolute sense. It will be cakewalk for you to not to understand. So if with this clear in your head, which I hope you have written in your notes, let's just straight away get to the second law of motion, and this is the third part, and in which we'll finally prove that the first law is actually contained in the second law. So now let's see, can we use our concept of inertia, which we understood, which means that state of inertia also means a state of no acceleration, and can we use this concept to therefore prove that the first law is contained in the second law. For that, let us first write the second law, which is F into mass times acceleration, in which Newton gave us a formula, a mathematical formula, in which we can actually calculate the force acting on an object, and that is the famous formula F is equals to ma, which gives nightmares to students in both remembering in the exam and using to solve numericals. But let's see, can we use this equation to prove the first law of motion, which is the law of inertia. To do that, we need to expand this formula and write it in this way. See, if you know the formula for acceleration, which is this A, acceleration is equals to v minus u by t, which is change of acceleration upon time, which means the rate of change of acceleration, in which v is the final velocity, the velocity at which the object finally reached, u is the initial velocity, is the velocity at which the object started, which I already made sense to you from inertia. I hope it makes sense to you. So if acceleration is equals to v minus u by t, so in this formula we can change it, tweak it a little bit. We are not changing anything, we're just substituting the formula for acceleration, which is this, into the same equation, and still stays the same. But it is important for us to change it like that, because it is from here that we'll get the first law. So see, F is equals to mv minus u by t. Now if we're talking about the first law, which is the law of inertia, and like I said, in the state of inertia, if the object is continuing to stay in its state of motion, whether at rest or in motion, which is uniform motion, that it stays at the same velocity, if we are talking about the state of inertia, then we mean that v is equals to u. So in the state of inertia, v is equals to u. Therefore, in this formula, it will become v minus v, sorry, my v looks like u, v minus v by t, which when we solve, v minus v will be 0, which is m multiplied by 0, and any number multiplied by 0 is 0, and therefore we get 0 upon t, which will be equal to 0. So now we get F is equals to 0, force is equals to 0. This in itself is the mathematical formula for the first law, which you can see that in the state of inertia, where v is equals to u, where the final velocity is the same as initial velocity, the force acting on the object is 0, which is no net external force is acting on it, which is indeed the first law of motion itself, which you will remember from the first law, which I taught in the starting of the video, that if an object is in the state of inertia, which is v is equals to u, it's not changing its state of inertia, then the force acting on it is 0. If the force becomes non-zero, if the force increases to a certain extent, by which I mean that there is some external force, net external force acting on it, in that case the inertia will no longer exist and the object will come out of its inertia, which it means that if it is at rest, it comes into motion, and if it is in motion, then it comes to rest, or if it is in motion, then it accelerates. Therefore, force is definitely necessary to accelerate an object. If the acceleration is 0, the force by ma, if the acceleration is 0, then the force gets to be 0. The mass cannot be 0, but the force gets 0 if there is no acceleration, and no acceleration is the state of inertia, where the object continues to stay in its original state of motion. So you can see mathematically we have derived the first law of motion is written right here, that when we maintain the state of inertia, the force acting on it comes to be 0, which means in the state of inertia there is no net external force acting on it. If there is some net external force acting into it, then it cannot maintain its state of inertia, which means its initial and final velocity are different and are no longer same. I hope I was able to answer your question in very mathematical, clear, lucid terms, and it really helped you out. If you have any more questions regarding physics or any other branch of education, knowledge, whichever you are facing through, suffering through, not able to understand or not able to find the right resources to get it into your head, do let us know in the comment section below. We'll try to make a tutorial like this and get it to you as soon as possible on our YouTube channel. If this video helped you out, then do like the video, subscribe to the channel, because there is more such content coming on our channel every month, and I don't want you to miss any updates. For that, do not miss updates, subscribe to the channel. I hope to see you next time on VR Academy's YouTube channel.
Thanks for watching. Don't forget to like and subscribe.